Let's begin. Today's June 29th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So in today's puzzle, the following 5 criteria cards are used. Criteria card 10, 13, 18, 19, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A looks at our 3-digit solution, and the Turing Machine will let us know how many 4s are in our 3-digit solution. Are there no 4s? Is there a single 4? Perhaps 2 4s? Maybe all 3 are 4s. Criteria card B will take a look at the middle digit and the last digit, the square and circle, and compare them. So should the value of square be less than circle? Should they be equal, or should the value of square be greater than circle? Criteria card C will look at the 3 digits in our solution, triangle, square, and circle, and add those digits together. The Turing Machine will let us know whether the sum should be an even quantity or an odd quantity. Criteria card D will look at the first 2 digits, triangle and square, take their sum, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will again take a look at our 3-digit solution and will let us know something about its structure. Specifically, either it will have a pair of digits or repeating digits, as in the example 131, or alternatively, there will be no pairs. And there are 2 scenarios. Either all digits are distinct, different, as in the example 134, or all digits are the same, as in the example 222, a single digit repeated 3 times. Now remember, the objective of the puzzle is to find this one unique 3-digit code that abides by all the criteria cards we just discussed. And we're going to start off with our initial proposal of 314. So the first thing I want to find out is I want to know what the sum of the 3 digits will be. So I'm going to test criteria card C. Okay, so the Turing Machine approves of my proposal. Notice that I do have 314, so if I add them up, 3 plus 1 is 4, 4 plus 4 is 8. So the Turing Machine confirms that the sum should be an even quantity. So that's what I'm going to type in our notes in section C, that triangle plus square plus circle should be even. And what that tells us, obviously it's a bit early, but we can make certain conclusions or potential conclusions, and that is that either all 3 digits are even, since the sum of 3 evens remains even, or potentially I could have 2 odds, and the sum of 2 odds is even, and then added to an even digit. So in both of those scenarios, either all 3 are even, or I've got 2 odds and a single even. So at least I'm guaranteed to have at least 1 even. And so that's kind of what we have so far. Now I do notice that we do have this criteria card E that potentially could identify a pair, or they could be all distinct. And so let me go ahead and test criteria card E. Okay, so the Turing Machine does not approve of my proposal of 314. Notice that 314 is one of the scenarios under no pair, right? All the digits 1, 3, 4 are sort of mixed up, but it's all the same. So it's true that there are no pairs. That's not a valid. So let me rephrase. That means that there is a pair. So let me write that down in my notes for section E, that there is a pair. Okay, so what that means is, that means that I do have a pair, but we don't quite know if it's even or not. So the pair is even or odd, and then I'll say with an additional even digit. An additional even digit. And so as we explained earlier, from criteria card C, you are going to have two of the same kind for sure. And so that's what we have identified now in criteria card E, that they will be equal. Not only are they the same kind, either two odds or two evens, but they will be identical. And so, let's see. We do have this criteria card that'll tell us how many fours. So it could be that if there are two fours, then there will be, I guess, the other one would have to be a 2. Or it could be that there's only one 4, and then the pair could be either 2 or 2 odds. So let's see, what else can we test? Because we really haven't crossed out anything. We could try criteria card D, and typically, that's been, it's not guaranteed, but and I may be a bit biased, but sometimes it's often a 6, but that would be that you'd have to have a 2 and a 4, and I'm not sure what I'm looking for. I think I'm going to test, I'm torn between B and D. It could be that B, well, that could be the equal part. That could be the equal part. So if it is 6, it could be something like 2, 4, 4, right? Or 4, 2, 2, if they're all even. I'm going to go ahead and test criteria card B and just see how square and circle compare. So let's go ahead and do that. Okay, so it does not approve of what I have so far for square and circle. Notice that I do have a 1 for square and 4 for circle. So that means that since this is incorrect, that means either square and circle are equal to each other or square is greater than circle. So let me go ahead and type that up for in section B, that square is either equal to circle or square is greater than circle. So unfortunately, I don't think we can actually eliminate anything based on that. If they're equal, they're equal. If it's greater, it's greater. Okay, this is very interesting going into our second round. We did already do or complete our three Turing tests for round one. So now we're going into the phase where we'll discuss options to construct a good second round proposal. All right, so we didn't test the number of fours, and we didn't test the sum of the first two digits. So very interesting indeed. So again, we do need to construct something that has two equal either odds or two equal evens, and then a second even. And the only thing we know about square and circle is that square has to be either equal to or greater. Equal to or greater. Yeah, and I don't think we can cross out anything. Wow. Okay. So, again, thinking of two odds. So let's just say that they're equal. Let's pretend that they're equal. The only thing, well, yeah, there is this card for criteria card D that may point us in the right direction as far as what it could be. And, there is that equal 6 that I mentioned earlier. So I am sort of, again, biased or leaning towards something like maybe either 422 or 244. So if it is 6, and again, I guess we do have that card of how many evens. So I'm going to say that there's a single 4 and two 2s. So I guess it would have to be 2, 2, and then a 4 for triangle. So I'm going to say 422 and hope for the best. 422. Okay, so since basically this proposal really came about from criteria card D, let me go ahead and test D. Okay, so no, it is not 6. It's not 6. Okay, let me see. Let me type that up, and then I'll see if I can come up with some sort of conclusion or things that we can discuss. So that was section D, or criteria card D. So we know that triangle plus square is either, the sum is either less than 6 or greater than 6. Okay, so what can we say about triangle and square if they're not equal to 6? Well, we know it wouldn't be 4, 2 or 2, 4. Can we say definitively? No, we can't really say definitively that you can't have 2s and 4s, because you could still have, either 2 2s or 2 4s, and the sum is, less than 6 or greater than 6. So we know that much. But typically, what that also might mean is that you might be dealing with an even and an odd. Let's see. Yeah, I still can't. Wow, I'm totally surprised. I've done 4 Turing tests and I have yet to cross out anything. Because, yes, of course, it can't be 6, so it can't be 1, 5, but it could be a 1, 3, or a 1, 2, 1, 4. Something to that effect. Wow, I am shocked. Am I missing something? All right, well, let's go ahead and test. I guess we haven't done A. We haven't done A, and I guess we could. Yeah, we haven't done. Okay, we did do D, but that didn't tell us. All we know is not 6. Okay, so yeah, let's do A. This is very interesting. Okay, so that did not, I mean, it does let us know that there's not just a single 4. So, okay, so let me say this. I don't think there could be 3 4s, because if there were 3 4s, then we would know that square equals circle. And I think based on kind of gameplay for Turing Machine is that every card should bring something to the table. So I think it would be irrelevant if it was all 3 4s. We would know that that would be equal. We would also know that it would be even, and of course then, well, then we would know that there'd be no pair. So I don't think it's 3 4s. We know it's not a single 4. So either there are 2 4s or no 4s. So let me phrase it that way. There are either no 4s or 2 4s. So that could be our pair of 4s and a 2, but it's not a 6. So that means the 2 would go here. But I'm kind of torn to see. Okay, it's 4 4. So if the pair was up here, well, I'm not sure. Okay, and I have again yet to cross out anything. Yeah, so this puzzle had, well, I guess B and D both had multiple options. So that kind of makes it a little bit difficult. It's not a 50-50. So we got one more turn. We know we don't have to do C. We could do B and zero in on whether it's less than or equal. I think that's our only option. So let's do B. Okay, so that is also incorrect. So it's not equal. So that means that it must be that square is greater. Okay, finally we have something that we can kind of cross out. Let's see. Nope. Oh, there we go. Okay, so we'll cross out this since they are not equal. And so we can say for sure that square is greater than circle. So if square is greater than circle, that means square can't be 1, because if it is the greatest, what would circle be? Can't be anything smaller than 1. And circle can't be 5, because if circle is the smallest and it happens to be 5, what would square be? Can't be anything larger than 5. Okay, so that's it for round 2. Okay, so that means that the pair has to be triangle in either square or circle. But we still don't know if it's 2 4s or something else. So can it be all evens with 2 4s? So again, that would mean Again, now we've reached the end of round 2, so we're thinking about how to construct a proposal for round 3. So it's either 424, which isn't possible because 2 is not greater than 4, or 2, well, no, it's not 244. It has to be squares bigger. So I guess 442 is a possibility. And I think that may have to be the only possibility, because if they were all even, again, square has to be greater than circle. So if it's all even, it would have to be 4 in the middle and then 2 for circle. So you're guaranteed that square is bigger. So 442 is one of the possibilities, and it's the only all even possibility. So let me see if I jot it down. And again, that's the only possibility. Is that right? In order for square to be greater among all evens, 4 has to be greater than 2. And yeah, so it wouldn't be 2, well, we know it's not 242 because that's a single 4, and we already know that that's invalid. So it would have to be 2 4s. And so yeah, so that means triangle would have to be. Okay, and if that's the case, what about odds? Well, it can't be a single 4, we said that. So that means it would have to be a single 2. And because we know that square has to be bigger, we know, let's see, we only did criteria card D once, and it was 6. It could be 1 2 1, because we do need to have an even. Oh, that's okay. So that's interesting. Yeah. So either we do have the 2 4s, or there are no 4s, and then yeah, it would have to be 2. And so if 2 is square, the only thing it could be greater than is 1. So that means it would be 1 2 1. 1 2 1. What if that's, I think, if square were 2. If triangle were 2, so it can't be that triangle is 2, because that would force square and circle to be equal, and we know that that's not true. So that means the only other possibility is if 2 were circle and triangle and square are paired up. Well, it can't be 3 3, because that's equal to 6. So it would either then have to be 5 5 2. Very interesting. 5 5 2. Of course, it's not 4 4 2. Well, it could be 4 4 2. I already have it listed. So let's take a look. So this is interesting. Notice that we do have, even though criteria card A would distinguish between the first and last, both of these have a sum that is greater than 6, which would be this option here. So it could be that it's greater, and then criteria card A would distinguish between both of them. Otherwise, the sum would be less than, and you're done. So I'm thinking, could it be that it can't be 1 2 1, because if the sum is less than, you can't have 2 4s? Is that possible? Can you make that statement? What kind of sum? I'm almost thinking, well, could it be 2 4s, or could it be not 2 4s? I'm not sure how the Turing machine would create a puzzle. But I think those are all of the options. So the question is, how do we want to proceed? Which one do we want to test? So technically A and D are still outstanding. And it could be that, yeah, there are no 2 4s, so you're kind of forced to pick between these two. And then you would again have to test criteria card D. So I'm looking at least 2 turns. How can is there a way to, if I test this, then I eliminate 1 2 1, but I still would have to test the number of 4s. If I test that and it's 1 2 1, then I'm done. But if not, I would have to test the 2 4s. Yeah, I don't think I have any. Well, hold on, let's see. Yeah, it is true that the middle digit is greater than the third digit. 4 2 2 1 5 2. Yeah, so that's good. They're all even. Yes, and there is a pair. Okay, so I'm going to go with 5 5 2. Yeah, let's go with that. 5 5 2, and I'm almost positive that sum will be greater. Yeah, there's just no way. Yeah, let's just go ahead and do criteria card D. Okay, yeah, so the sum is greater than 6. So let me go ahead and cross out the less than option. So we know it is greater than, and then I still have to test A. So let's see. Yeah. Okay. So it's not 4 4 and it's not 4 4 2 and it's not 1 2 1. So I deduced correctly, but I am not sure if I could have made it using less criteria tests or Turing tests. Okay, so wow, did not cross out many numbers here, but I did come up with a solution. So let's review very quickly. So criteria card A, basically, yeah, I should actually update it here and say there are no 4s. So let me cross this out. And that's definitive. There, well, again, we're deducing that that it's not 3 4s. So no 3 4s, no 2 4s, and not a single 4. So no 4s. That's correct. It is true that the middle digit is greater than the third digit. Yeah, 5 is greater than 2. The sum is even. The sum of the first 2 is greater than 6, and there is a pair. I guess, and because it's not a pair of 4s, it must be a pair of odds. So there's a pair. The pair is, and again we'll cross this out, pair of odds with a single even. Okay, so that looks like the solution. So let's go verify. So 5 5 2. Oops, 5 5 2. And okay, yes, but I'm concerned about if we beat the Turing machine or not. So we did do it in 8. So let's see, what did we do? We did B, C, E, and then A, B, D. So, and the only one correct was C for that one. So B, C, E. B, C, E, and then A, was wrong, D was wrong, and I don't quite remember if I did B or C. It was A, D, and B that was wrong, and then A, D in the last turn, and they were correct. So B is wrong, and then A, D. B is wrong, and then A, D were right. So we did an 8 Turing test, and wow. That may be the, have I lost by 2 questions before? I don't remember. If not, I don't think it's happened that often. So yeah, so it took me 8 Turing tests to get the question. So I'm wondering how was I inefficient? More than likely, again, having to do with these 2 criteria cards. I probably should have tested D instead of either C or E, just to kind of get them out of the way. That may have helped out. I'm not sure. Of course, it could be, the proposal itself, starting out with 314. But yeah, just almost like, if not the first 2 rounds, I hardly crossed out anything. And so, yeah, so it took me 1 whole round, 2 Turing tests in a 3rd round to get the answer, and they did it, the Turing machine did it in only 2 rounds, 6 Turing tests. Yeah, so I'm not sure how I could have made improvements, but definitely need to rethink that strategy. Well, that was the puzzle for today. Again, if you do have any comments, please do add them. If you like the video, maybe not the results, but if you like the video, please do give it a thumbs up. And if you don't want to miss out on any future videos, please subscribe to be notified. Well, until next time, have a great one.